Oh yeah, I forgot to put the date on last time. March 17th, 2017, St. Patrick's Day. Flare transitioning and stellar metamorphosis. I wrote another paper here. And flare transitioning is exceptionally important because it marks it's the demarcation area between red dwarf to brown dwarf stages of stellar evolution. I've also printed out this little graph here. Of course, a lot of the diagrams and interpretations we have here are, odd, but for the most part, for my listeners, flare stage is between red dwarf when it cools and it starts ejecting matter and cooling extremely rapidly until it reaches brown dwarf stage. So it goes down, it hits flare stage, and then it keeps on going. The paper I wrote here, it's fortunately very short, so here we go. Flare stars signal the transition of red dwarfs to brown dwarfs in stellar metamorphosis. Remember, they don't have a transitional stage in establishment astronomy. They believe red dwarfs and brown dwarfs are completely mutually exclusive. They're not related to whatsoever. To them, a brown dwarf is a failed star, and a red dwarf is something that's going to be a really old star. They don't realize that red dwarfs become brown dwarfs as they cool and die and lose mass. But here we go. In stellar metamorphosis, exoplanets are evolving stars. Since they are the same objects, they have the same evolutionary timeline. Since they have the same evolutionary timeline, their evolutionary past can be inferred by their physical appearance. In this specific case, it can be inferred since brown dwarfs are cooler and smaller than red dwarfs, then they were at one time actual red dwarfs, not failed stars. This means that they are not only vastly older than what mainstream dogma accepts, sometimes as young as 23 million years old. Yes, they have brown dwarfs as being 23 million years old. Remember this little diagram here? There's no way a brown dwarf is only 23 million years old. 23 million would make it like in the white star stages, like really, really, really hot. They have cooled significantly. They're around 250 to 300 million years old at the bare minimum. But that their transition from their hotter star stages is signaled by the stage known as flare star. This is a stage with which the main polar magnetic field of the star overcomes the fields of the surface activity. This in turn is caused by the iron-nickel core beginning formation and aligning the star's magnetic field internally. The electromagnetic turbulence of this process is what causes the flares. Since the flares are extremely powerful, the star loses mass much more rapidly than previous stages of stellar evolution. Of course, then it, dies down and it remains stable for very, very long periods of time. If any scientist wants to figure out if the star is past flare stages or not, all they have to do is figure out if it has a strong polar magnetic field. If it does, then flare stages have passed. If it has a turbulent magnetic activity and is in the temperature range of red dwarfs, then it has not passed flare star stages, and the scientists will probably see flaring events if they pay attention to the star. So basically it means if you have a single polar magnetic field, or where, the north and the south on a star, just like Jupiter does, then it's probably past flare stages. If it doesn't, if a lot of the sunspots and surface activity have really strong magnetic fields, then it's probably this probably hasn't gone through its flare star stages yet. So it's still sort of, in its red dwarf stage. But what happens is those strong surface magnetic fields, like in the sun where you have those huge prominences, if it can't form those, well, what's going to happen is the star will become a single magnetic field because it will start clumping together in the center iron and nickel, and that will stabilize any type of magnetic activity, because the iron and nickel obviously will be, that will act as the what do you call it? I can't remember the word, but it'll stabilize that field, and the field will become a polar field, overcoming all the surface activity and stabilizing it. But that's very important. And another note, this is for future reference, I do want to go over Cepheid variables. In stellar metamorphosis, I guess Cepheids would be very young, and their variableness, I have yet to determine if it high variability or low variability determines how old they are. I also don't know if there's any connection there, but Cepheid variables are what Hubble used to determine galactic distances. Those are around this area up here. I believe they're very young stars, no doubt, but if we can determine what's happening with them, after they're